Hi everyone. In this video we are going to graph the tangent function. So all about our tangent graph. Okay, so just a reminder, tangent theta, or tangent of x, tangent of whatever angle, is always going to be the value of sine, so sine theta, divided by the value of cosine theta. So whatever angle you're talking about, it's going to be the sine value divided by the cosine. That's going to give you tangent. So when we're looking at our unit circle, we don't always write our tangent values, but we can get them really easily by taking sine and dividing by cosine. Okay, so let's get our table of values first so that we can graph them and see what our tangent graph looks like. Okay, let me change up my color. So for our table, let's get our input-output table drawn. So I can input some x values and get some y values out. And let's start with a really easy one. If I input 0, well, sine of 0 is 0, and then cosine is 1. So 0 divided by 1 is just 0. So 0, 0. Next kind of easy value, we've got pi over 4. Now that's a little different than when we were doing sine and cosine, because look at the values for sine and cosine for pi over 4. They're both the same. So when I take square root 2 over 2 and divide by itself, then I just get 1. So tangent of 45 degrees is 1. Very similar to the negative of 45 degrees, it's going to be negative 1. Okay, then we have pi over 2. This is going to be undefined, and let's talk about why. So pi over 2 is 90 degrees. 90 degrees, sine is 1, and cosine is 0. 1 divided by 0, oh, well, we can't divide by 0 in math. So that value, well, it's undefined. We can't find tangent of pi over 2. Then we have pi, or 180 degrees. Pi is sine over cosine for tangent, so 0 divided by negative 1, that's going to be 0. And then the last one we'll put in our table here is 3 pi over 4, okay? So 3 pi over 4 is going to be negative 1 if we take the sine and divide by cosine. All right, so we've got a good number of values here. Let's get started graphing them. Now this shape is not going to look like our sine and cosine. It's going to be a lot different. So let's see what happens here when I plot these values. Okay, so the first one we've got is 0, 0. We've got, so pi over 4 is halfway between 0 and pi over 2, right? So I'm going to go halfway, pi over 4, and up 1. That's my next value. And then my next one is pi over 2, but that one was undefined. So we're not going to put a point yet. I'll show you what that means in a moment, but we'll move on and plot the next couple points. So 3 pi over 4 is 1 more quarter over, and that's going to be negative 1. So if I go 3 pi over 4 down 1, that's my next point. And then pi is 0. Okay, I also had some negative values, so I'm going to plot that as well. Negative pi over 4 was negative 1. And then we didn't have it in our table, but if I go 1 more quarter over, I'll go up 1. So we've got an interesting set of shapes here if I were to connect these. But something special happens at our values where tangent is undefined. And what happens is we have what's called an asymptote. So at pi over 2, I'm going to draw an asymptote because our function approaches this value but does not reach it. Same thing actually happens at 3 pi over 2 and so on. And then we also can jump over to our negative pi over 2, and that's also an asymptote. Same thing with negative 3 pi over 2. So remember, the reason we have an asymptote is because if I were to try to find the tangent value of these angles, you would be dividing by 0, and that gives you it's not a value. We can't divide by 0. So that means, remember, when we have an asymptote, You never cross it. That's the whole point of an asymptote. You approach it, but you don't actually touch it. So I don't know if you guys can hear Phoebe's running around in the background. We are going to go through these points and then approach our asymptote. But if I want to connect to this point, I now have to go down and approach this asymptote in this direction. So our tangent graph is this shape right here. You can notice that's a lot different than our sine and cosine. Then what happens, just like sine and cosine, is this repeats. It repeats over and over and over again, infinitely, to the right and to the left. So I'm just going to, again, go through my points here and approach my asymptote. Same thing happens in my negative direction. In each period, remember we call each full cycle a period, we have our value at 0, and then it approaches my asymptote in this direction and in this direction. Okay, and again, those continue forever in the positive direction and in the negative direction. So just like we did with sine and cosine, let's just quickly talk about what our amplitude is and what our period is. Okay, so the first one is our amplitude. Okay, so let's talk about how far these graphs go up and how far they go down from, remember, our midline right here, which is our x value, or x-axis. Well, this is going to continue forever in the positive direction, and this is going to continue forever. So it's never going to end. We can't actually measure how far up or down it goes. So this is undefined. We don't really have an amplitude. And then our period, how long do we have to go on our x-axis to create a full cycle? Well, from one asymptote to the next, the distance is pi. So it's actually half of the period of sine and cosine. So see, if I started at negative pi over 2, then if I were to move over, that's pi over 2 and another pi over 2. Well, 1/2 plus 1/2 equals 1. So your period is 1 for tangent. Okay, so again, this is our parent graph. We're going to use this now when we start doing transformations, so we know how the tangent graph began, what its original form is, so that we can transform it. All right, guys, thanks so much for watching. Stay tuned now for our transformation videos.